Okay, let's try something that sounds basically impossible. We're going to tell the entire story of our planet, a saga that spans 4.5 billion years in just the next 5 minutes. Yeah, we're going to try to boil down all of cosmic chaos and the rise of life into one single wild ride. Our story kicks off 4.54 billion years ago. That's a number so big, it kind of breaks your brain, right? To put that into perspective, if the entire history of the universe was a single calendar year, our Earth wouldn't have even formed until late August. This is our planet's age, and our journey starts at the very beginning. So, how on earth do you even begin to tell a story that long? Well, the truth is, you can't tell all of it. The only way to even try is to break it down into its biggest, most world changing chapters. And that's exactly what we're about to do. So, our story is going to unfold in 5 acts. First, we'll witness Earth's violent molten birth. Then we'll check out life's mysterious first steps. We'll explore the one event that completely terraformed our atmosphere, watch the explosion of complex visible life, and finally, we'll get to the age of mammals and, well, us. All right, let's dive right in. Act 1, a violent molten birth. Our story doesn't begin with a peaceful creation. No, it starts with pure, unfiltered cosmic chaos. So the leading theory is that it all started with this giant spinning cloud of gas and dust. Something, maybe a nearby star exploding, gave it a nudge and it started to collapse and flatten into a disk. From there, gravity just went to work. In a process called runaway accretion, tiny specks of dust clumped into pebbles, pebbles into rocks, rocks into boulders, and on until after about 20 million years, a baby Earth was born. They call this first eon of Earth's history the Hadean, and for good reason. It's named after Hades, the underworld, because honestly, the young planet was a total hellscape. It was a ball of molten rock with insane volcanism, and it was constantly being smashed by asteroids and comets. And maybe nothing shows off that violence better than how we got our moon. The leading idea, called the giant impact hypothesis, is that a protoplanet about the size of Mars, they call it Theia, slammed into the young Earth. The impact was so huge it literally blasted a giant chunk of our planet's crust into space, and that debris eventually came together to form the moon. It's a pretty wild story, but it perfectly explains why the moon has a tiny core and why its chemistry is so similar to Earth's. So, after all that chaos, things finally started to cool down. The stage was being set for what is, without a doubt, the single most profound event in our planet's history, the origin of life itself. Now, to keep all this straight, geologists break down this huge timeline into 4 great eons. Think of it as our roadmap. We just survived the brutal Hadean. Next up, we enter the Archean, where life first appears. After that comes the Proterozoic, the era of early life, and finally the Phanerozoic, the time of visible life, which is the eon we're still in today. Okay, so picture this. The planet's finally cooling enough to get a solid crust. Volcanoes are just erupting everywhere, pumping out gases and creating a whole new atmosphere, but one with pretty much zero oxygen. And because it was cooler, water vapor could finally condense, and it rained, and it rained, and it rained for centuries, until it formed the very first oceans. And that brings us to one of the absolute biggest questions in all of science. You've got this warm, chemical-rich ocean, this primordial soup. How in the world did non-living chemicals suddenly spark into life? This is the great mystery of abiogenesis. You know, scientists are still debating this one. There are a few big ideas on the table. The RNA world theory says life started with simple self-copying RNA molecules. The metabolism first idea suggests it began with chemical reactions that could sustain themselves, maybe near deep-sea hydrothermal vents. And then there's the membranes first idea, which says the key was protective little bubbles of fat forming first. We don't have the final answer, but we know it happened. The oldest fossils we found date back a whopping 3.5 billion years. For over a billion years, life stayed simple, microscopic. But then these tiny little organisms pulled off a trick that didn't just change the game for life, it changed the entire planet. And that trick was photosynthesis. Early microbes called cyanobacteria figured out how to harness sunlight for energy. I mean, what an amazing evolutionary innovation. But it came with a side effect. It produced a waste product, a gas that was totally new to the atmosphere and totally toxic: oxygen. And just look at the unbelievable transformation that happened. The early atmosphere was this nasty mix of methane, CO2, and nitrogen, but over millions of years, these tiny bacteria completely terraformed our world, pumping out oxygen and creating the very air we're breathing right now. This whole event was both a catastrophe and an opportunity. For the life that existed at the time, which couldn't handle oxygen, it was a poison that caused one of the first great mass extinctions. But for the future, it was everything. This is what gave us the ozone layer, and it paved the way for a much more efficient way to make energy, breathing oxygen. So, with a new atmosphere and new energy sources, the stage was finally set for life to get big, to get complex, and to finally conquer the land. We've officially arrived in the Phanerozoic Eon, the age of visible life. About 539 million years ago, it seems like evolution just hit the accelerator. In a geological blink of an eye, life just exploded with diversity in an event we now call the Cambrian explosion. Almost all the major animal blueprints we see today appeared for the first time. And, crucially, animals started developing hard parts like shells and skeletons, which is why we have such an amazing fossil record of all these wonderful, bizarre creatures, like the famous trilobite. And from here on out, the pace really picks up. First fish show up in the oceans. A little later, the first brave plants and bugs make the jump to land. Then, some fish evolve into four-limbed tetrapods, our own distant ancestors, and take their first steps on solid ground. This eventually led to the age of reptiles and, of course, the incredible 150 million year reign of the dinosaurs, a reign that came to a spectacular, fiery end 66 million years ago when a giant asteroid hit the Earth. And that asteroid was just one of at least 5 great mass extinctions our planet has seen. This statistic is just mind-blowing. It really puts things into perspective. Extinction isn't some rare event. It's a fundamental and often brutal part of life's long story on this planet. The end of the dinosaurs was a tragedy for them, but it opened a door. A whole new class of animals, one that had been waiting in the wings for millions of years, was about to have its moment. And those animals, of course, were the mammals. For over 100 million years, our ancestors were these small, shrew-like creatures, basically just trying to avoid being stepped on by dinosaurs. But with their giant competitors suddenly gone, mammals just took over. They exploded in diversity, evolving to fill every corner of the planet. In the air as bats, in the oceans as whales, and on land as, well, everything in between. And in all of that time, in this entire 4.5 billion year story, this is when we show up. Modern humans, Homo sapiens, evolved in Africa just 200,000 years ago. If the geological clock was a 24-hour day, we arrived in the last few seconds before midnight. That's it. And that leaves us with a pretty profound final thought. We are the newcomers. We're the product of this unbelievably long, fragile, and chaotic history of cosmic collisions and evolutionary twists.